A very brief word before we start the show. We've got a survey for listeners of Catalyst and Open Circuit, and we would be so grateful if you could take a few moments to fill it out. As our audience continues to expand, it's an opportunity to understand how and why you listen to our shows, and it helps us continue bringing relevant content on the tech and markets you care about in clean energy. If you fill it out, you'll get a chance to win a $100 gift card from Amazon, and you can find it at latitudemedia.com/survey, or just click the survey link in the show notes. Thank you so much.
Latitude Media, covering the new frontiers of the energy transition.
I'm Shail Khan, and this is Catalyst.
As a third-party contractor, your incentive is really, we only make money when the project costs more and takes longer. So yeah, high level, what's broken is it's the incentive structure.
Coming up, is there a better way using modern technology to build big capital projects?
Surging electricity demand is testing the limits of the grid, but Energy Hub is helping utilities stay ahead. Energy Hub's platform transforms millions of connected devices, like thermostats, EVs, batteries, and more, into flexible energy resources. That means more reliability, lower costs, and cleaner power without new infrastructure. Energy Hub partners with over 120 utilities nationwide to build virtual power plants that scale. Learn how the industry's leading flexibility provider is shaping the future of the grid. Visit energyhub.com.
Clean energy is under attack, and it's more important than ever to understand why projects fail and how to get them back on track. The center-left think tank Third Way surveyed over 200 clean energy professionals to answer that exact question. Their newest study identifies the top non-cost barriers to getting projects over the finish line, from permitting challenges to NIMBYism. To read Third Way's full report and to learn more about their PACE initiative, visit thirdway.org/PACE or click the link in the show notes. The AI boom is here, but the grid wasn't built for it. Bloom Energy is helping the AI industry take charge. Bloom Energy delivers affordable, always-on, ultra-reliable on-site power. That's why chip makers, hyperscalers, and data center leaders are already using Bloom to power their operations with electricity that scales from megawatts to gigawatts. This isn't yesterday's fuel cell. This is on-site power built to deliver at AI speed. To learn more about how fuel cells are powering the AI era, visit bloomenergy.com or click the link in the show notes.
I'm Shail Khan. I lead the early stage venture strategy at Energy Impact Partners. Welcome. All right, so here's a cycle that I have seen play out many, many times. Developer X of project Y wants to go build a big new project. And somewhere in the development process, they engage an EPC. EPC being an engineering, procurement, and construction firm. There are many of them. Many of them are very, very large. And they're kind of ubiquitous if you're going to build a big capital project. They engage the EPC, and then there's like a fairly painful process from there on where it's slower than they want it to be. They have to go through multiple cycles of iteration. There's value engineering. The cost comes in higher than they expect. And then at the end of the day, there are a bunch of change orders anyway. And there are cost overruns. There are time overruns. It's not necessarily the fault of the EPC, right? Lots of things can happen in the world. But the process of actually getting big projects constructed is notoriously hard. And some folks have been wondering whether there is a way to leverage modern technology, AI included, to do it better. Certainly that is the opinion of Alex Modon, who is our guest today. Alex is the CEO and co-founder of Unlimited Industries, which is a startup that recently unstealthed to basically be a modern EPC. They're trying to start from scratch to build a company that will do engineering, procurement, and construction with new technology, with a different business model to try to get projects built faster, more on budget, potentially cheaper. It's an interesting question, and it applies to everything from data centers to power generation projects, battery storage projects, new chemical plants, anything that we might build that's a big capital project. So it's relevant to basically everything else that we talk about here. Anyway, here's Alex. Alex, welcome.
Hello, thanks for having me.
Thanks for being here. Let's talk about EPC, engineering, procurement, construction. You founded a company based on the premise that it could be done better. So I want to start with what's wrong with it today. As you've observed EPCs and how they work, like fundamentally, what is the problem that you see?
Yeah. Well, it might be first contextualizing like what is EPC and where does it play in the value chain. So to start this, let's just imagine we're going to build, I don't know, let's just say a data center project. So if we want to go build a data center project as an owner of a project or a developer of a project, the first thing that we do is we kind of find the land and we contract that and we start to figure out what permits we need. We figure out what power we need to buy. And then, you typically go find an off-taker or some sort of tenant for that actual data center project, or again, whatever the product is that comes out of the facility. And the last like big contract that you're trying to do is go find the third party that's going to design and build the thing. EPC, engineering, procurement, construction, is basically the vertically integrated, or all three of the kind of design, manage the supply chain, actually manage the build of the project. All three of those in one contractor. And they're, for all intents and purposes, they are the people who design and build the thing, that EPC piece. And so I think when I got into it, I was actually really excited the first time we went to go work with an EPC, thinking that there's going to be all these different kind of disciplines and institutional knowledge under one shingle. I think the biggest thing that's challenged with the industry today is that the incentives between the developer, the person who actually wants to build the thing better, faster, cheaper, or some sort of metric like that, versus the third party, the incentives are so fundamentally misaligned because of how these contracts get produced. And so you either have, the vast majority of these contracts have some element of cost plus, where, we'll say, we'll give some sort of guidance about how much the project's going to cost. But as a third party contractor, your incentive is really, we only make money when the project costs more and takes longer. Or there's sometimes these contracts that run on a fixed firm basis, where that third party will actually say, hey, we'll build it for this much. But they define the contract so tightly that inevitably what happens is when you learn something through the design process, or when things change, which inevitably they always do, you get issued these like massive change orders. And that's at that point, that's where that kind of third-party EPC typically makes all their margin, just because you're already working together and you can't really easily leave. So high level, what's broken is it's the incentive structure. The incentives between the third party, or the actual developer who wants to build better, faster, cheaper, and the third party who's in control of making all the decisions about what gets designed and what actually gets built.
If I'm being charitable to EPCs, and and I ask the question of like, why is it cost plus typically, or fixed firm, but where change orders are the norm? I would imagine in part it is because there's this like time lag, right? Like they're signing the contract on day one, but they're actually procuring the commodity materials 6 months later, a year later, 18 months later, whatever it might be. Those prices are volatile. They would have to hedge them every single time if they weren't going to do that. And not to mention labor availability, labor costs, and all this other stuff. So is it because they just can't wear that kind of a risk, the like time risk? Or is your experience that there's a different reason why it ended up being cost plus or fixed firm with all sorts of change orders?
No, definitely to Steelman. It's because it's ultra complex to build these projects. There is hundreds of people that'll be involved in how the thing gets designed, that manages the entire supply chain to get it built, and then manages all the like boots on the ground of the project that's actually doing the building. So there is tons of complexity. And the reason that these contracts are structured in this inherently flexible way is because it's really hard to know upfront how much exactly is the thing going to cost. So it certainly is like evolved this way, because when you think about these projects, and the small version of these are like $100 million. The more normal version of these is many hundreds of millions, and then the bigger ones are certainly in the meaty billions of costs. So, because you have all of that risk, the contracts effectively are this big risk mitigation strategy, and that the easy way for the EPC not to take any risk is just to say we're going to get a margin on top of what it costs us to build the thing. But the problem is that there's no motivation then to like make the thing cost less. If anything, there's a motivation the other way to make it cost more.
Yeah, you mentioned there's a lot of people and a lot of uncertainty. I guess one way I think about it is that there's a spectrum of different types of projects. On one end of the spectrum is a thing that looks the same every time you build it, more or less. Maybe a version of this would be, I don't know, utility scale battery projects or utility scale solar or something like that, where like we've built hundreds of them. They generally look the same wherever you go. And you would imagine that on those types of projects, it would be pretty well known. Maybe there's some commodity risk, maybe there's some labor risk, but like broadly speaking, the designs are going to be similar and the experience is high. And then on the other end of the spectrum, there's like a first of a kind thing that's never been built before. And there, obviously, your error bars on the cost and the time, the labor and all that is going to be highest. And then there's a bunch of stuff in between. I imagine data centers are in between, actually, because in some ways they look the same. There's like a powered shell. The shell is a building. But then inside the data center, right, like there's all sorts of innovation. Like, is this one liquid cooled? Is this one using, which NVIDIA chips is it using? How is it designed? There's so much innovation in that space that it's changing all the time.
Which also changes the facility too, right? Like it's these
right.
changes trickle out for sure.
Right. So I guess as you think about this, like, the incentive structure being misaligned, do you view it as being more misaligned on I guess, relatively speaking, easier stuff to build? Because there you should be able to have high level of certainty on what the cost should be a priori? Or is it more misaligned on the esoteric stuff because the error bars are even higher, and so the risk aversion of the EPC leads them to like way overprice, for example?
Yeah, no, I mean, definitely it's like the contingencies or the egregiousness of this like cost misalignment is certainly true with the more custom the project gets. So the first of a kinds are a great example of that. Or like you even mentioned, data centers that are shifting in their requirements, of course, have more and more of this baked in. It's basically just correlated to risk. Like, how much risk is there in this? Solar has less and less risk as we deploy more and more the exact same way. Same thing with utility storage. But I do think that like where you see, so you definitely get misaligned contracts or misaligned incentives, which kind of balloon costs, and that is the kind of status quo for how you contract these things, anyways. But the other thing that kind of falls into this is how projects broadly are approached. And so if you think about how we build products, like we have a metric for it, right? We say, hey, we're going to make this widget. It's going to come out of a factory. We'll have some sort of cost per widget metric. And that allows us to kind of approach these projects with this continuous improvement type approach and drive costs down. That's like our learning rate. I think arguably like that's why solar has fallen so aggressively, is because we keep kind of making, or at least I should say the module costs, which is even different than, this is maybe a side tangent, but it's like different than the actual install costs. Yeah.
Well, it's actually the problem with solar is that the module costs have fallen much faster than the installed costs have, right? Like we haven't solved it on the construction and all the other commodity materials and stuff.
Yeah, and that's because all progress happens with this like, highly iterative process and this like continuous improvement process that we get out of manufacturing a thing. But when we move into projects world, everything's a snowflake. It's like, everything's N of one. Even a project that we're building, we built lots of refineries. That next refinery that we build is still an N of one project. And because it's approached in that way, you don't really get any sort of benefits of learning through that process. And, by definition, each project's going to be unique. It's a different piece of land. Yeah, and again, maybe this is a tangent, but that's like another big problem in the industry is everything's done from scratch. So even if you're going to go design a new, a slightly different data center or solar project or something else of that sort, every tweak or change that you make effectively reintroduces the entire redesign of the process. And so, yes, there's some stuff that gets lifted, but the overall amount of work that happens is not the kind of delta of the change. It is like a significant rehaul of work. And it just keeps us from like learning and iterating to improve how something gets designed, not just in terms of saving engineering costs, which is actually a pretty small piece of the cost anyways, but actually like having a better design that improves the overall cost or performance of the facility.
I guess one thing I wonder is, okay, so let's take EPC, right? Like in engineering, procurement, and construction, just taking it at the simplest base layer of what the work entails. Let's just say you could dramatically improve, because what you're describing is like the learning, I guess maybe is on all three, but predominantly on like engineering. Can you design this thing so that it's fast and easy to design and is definitely going to work up front? My guess is that in most of these big capital projects, the E out of EPC is the smallest slice of the pie in terms of total cost. And like the bulk of the cost probably comes from a combination of procurement, the actual physical materials, much of which are going to be like steel and cement and aluminum and, commodities that have prices that vary. And then construction, which is sort of a function. It's an outcropping of how the engineering occurs, but certainly is also just driven by construction process and labor and so on. So as you think about like, where is there an opportunity to deliver cost reduction and also cost certainty, like how much of it is the E versus the P versus the C?
Yeah, totally. Okay, so those are two separate things, right? Like, so let's say cost certainty versus like an overall reduction in cost. On the certainty side, everything gets really kind of planned out or teased out in the engineering portion, right? And so generally, again, life cycle of these projects are, you start with some conceptual design, you understand maybe plus or minus 50% how much the thing's going to cost. Then for the most part, you dig into this like front-end engineering design, and you will get to totally changes per project, but say you get to like plus or minus 10% of cost. And that gives you enough confidence to go to a lender, an actual bank, and say, hey, let's underwrite this project. We think you're going to get the IRR you need. And then we move forward. But in the vast majority of projects, when you go to final investment decision and you have plus or minus 10% estimates, you're only maybe 30% of the way through your engineering. 70% you still have to go do. And it doesn't make sense to do it up front because it takes a lot of time and it costs a lot of money, and it's a lot easier to finance that with the actual lender's money rather than the development capital. So the certainty that you have going into a project before you actually take the money from the bank to go build it is actually pretty low. Like there's so much more work to go do. And you just don't do it because there's a high marginal cost of the engineering. So one way that you really reduce all the risk, if you will, or all this like uncertainty from how the project's going to work is if you could instead just take these projects further through the design process so that by the time you're doing your earthworks or you're moving some sort of ground, you're actually 100% done. You have your issued for construction package, which doesn't happen today. And so there's that big piece on like, how do you remove uncertainty? How do you remove costs? I mean, yeah, you're totally right. The engineering cost is anywhere from like 3 to 10% or 15% of the project cost. So it's not a huge lever in itself. But if you think about the way these projects are designed today, because again, such a high marginal cost to engineering, what you end up doing is you only really design something one pass through. There's no sort of iteration. There's no optimization of design. And that leads you to a spot where you kind of make early decisions, you freeze those design decisions, you kind of do the next stage gate of your design process, and you eventually get stuck in these like very like low local optimums rather than ever understanding what the global optimum of that design process is. So, yeah, I mean, like I can get more into how we approach this problem, but there's huge gains and opportunities to use the E to rapidly reduce the P and the C.
The grid wasn't built for what's coming next. Electricity demand is surging from data centers to EVs, and utilities, they need reliable, affordable solutions that don't require building expensive new infrastructure. Energy Hub helps by turning everyday devices like smart thermostats, EVs, home batteries, and more into virtual power plants. These flexible energy resources respond in near real time to grid needs, balancing supply and demand. Plus, they can be deployed in under a year and at 40 to 60% lower cost than traditional infrastructure. That means more reliability, lower costs, cleaner energy. You can't get much better than that. And that is why over 120 utilities across North America trust Energy Hub to manage more than 1.8 million devices. Learn more at energyhub.com or click the link in the show notes.
Do you ever wonder why it takes so long to get clean energy projects up and running? Do you have permitting reform on the brain? Are you NEPA reform curious? The new PACE study from Third Way pinpoints the non-cost barriers that stand in the way of clean energy deployment and keep new solar and transmission projects in limbo. They surveyed more than 200 industry professionals to understand what's slowing down deployment and offer practical solutions on how to fix it. To read Third Way's full report and to learn more about the PACE initiative, visit thirdway.org/PACE. You heard the phrase speed to power a lot lately, but here's what it really means. AI data centers are being told that it will take years to get grid power. They can't afford to wait, so they're turning to on-site power solutions like Bloom Energy. Bloom can deliver clean, ultra-reliable, affordable power that's always on in as little as 90 days. Bloom's fuel cells offer data centers other important advantages. They adapt to volatile AI workloads, they have an ultra-low emissions profile that usually allows for faster and simpler permitting, and they're cost-effective too. That's why leaders from across the industry trust Bloom to power their data centers. Ready to power your AI future? Visit bloomenergy.com to learn more.
Okay, let's talk about how to use technology, which is, I think, what you're alluding to here, right? Like, this is an area where my suspicion is generally it's not the first category of AI adoption, or at least it hasn't been historically. Where do you see the biggest opportunity? Like, where are the step function improvements that one can achieve by leveraging modern technology, be it AI or something else?
Yeah. So we have built a lot of technology to help accelerate that pre-construction phase. So this is basically the E and lots of the procurement management side of things. And we have a software and kind of like an AI native version of this that helps accelerate the chemical design, mechanical, electrical, civil, structural controls. And in doing that, we basically are building a platform that allows us to remove that risk, but at a very, very low marginal cost. So that helps you accelerate through the design process, not just saving time, but exploring a much wider search base and getting to much greater levels of definition before you actually have to freeze designs. And that has a big impact to the previous point, right? It's just like removing uncertainty, reducing costs through optimization.
Can you go a level deeper on that? Like, what does that actually mean to reduce uncertainty using software? Like, what are you actually doing?
Yeah. It's just, if you start a project today at like zero, it's like completely uncertain, right? And as you start specifying or defining bringing definition to that project, which is the process of engineering it, you start to see more, you start to remove risk, right? You say, hey, we can actually size a pump that will solve that, moving a fluid from point A to point B. Or, actually we can design a tank like this to hold this amount of volume. And once you start providing that level of definition, you remove a lot of the kind of ambiguity, but there's still tons and tons that goes into, the thousands of documents that you'll kind of generate to design a plant fully. So this is what we kind of have built. Like it is a platform that our engineers use. I think the important distinction here is this is not like a software technology that we sell. It's like we use this as an internal tool ourselves. So our engineers have this kind of AI platform that has all of their data in one place, all of the kind of requirements about the project, all of the potential vendors that could be used, and they use it to basically accelerate that design process really significantly. We haven't like redefined how you're engineering these projects. We've kind of augmented it, like significantly augmented the people that are doing that work so that they're able to just, with the same amount of time and capital, they're able to define way more and provide way more kind of engineering definition as well as like time to optimize those designs. So you can remove kind of suboptimal design.
Can you articulate a little bit like what is distinct about this from the EPCs have been using engineering software that is super mature for a long time. Maybe that's the problem. But like, what's distinct about what you just described from what you could just get off the shelf to design a project?
Most of the software in this industry really hasn't changed much in the last like maybe 20 years. And I, again, kind of always come back to the incentive structure. There's no real incentive structure for an EPC to want better software. It's the same reason your law firm doesn't necessarily want like AI software to help them accelerate, and reduce their billables. So the way these softwares work now is that there's a bunch of kind of distributed software solutions or maybe decentralized solutions. So you'll have a CAD tool that you use to actually like do the designs. You'll do almost all of your kind of rough engineering or hand calcs in Excel. You'll use dedicated simulation software for some sort of fluid design or structural analysis or whatever that might be. And then you use another tool to like review those PDFs, with a tool to put red lines on them and go through design cycles and then push to drafters and then other tools to manage, how do you reach out to your vendors? And anyways, there's all these different solutions that software solutions that you're using in order to like kind of quote unquote like do engineering. And what we built kind of from day one was just a modern version of this software. So we put all those different disparate tools into one underlying platform, and we gave modern software to them, which is like, automatically doing version control and collaboration and everything that you would expect out of just like a modern tool. And what that allows us to do is not just kind of have much more streamlined workflows, but it allows us to kind of build AI in as a core primitive to the solution. So now sometimes our engineers will do some sort of work manually within one of our softwares, but often they will dedicate kind of delegate a task to an AI that knows how to use all those tools in our software so that it can do that design task and then surface that back to the engineer who delegated it.
So it's, at least in significant part, it's like integration of a bunch of what otherwise are kind of disparate workflows to allow for faster iteration and more automated iteration. Like you do a change somewhere in one piece of software right now, you'd have to go to another piece of software, like make the change in that software, see how it changes the other thing, do that over and over again. So it's like build everything into a single comprehensive suite, basically.
Yeah, totally. There's like one underlying data model. There's not, the same piece of data that shows up in 10 different softwares. And that's really helpful, not just, again, for streamlining your own workflows, but it's so that an AI can do it. And it doesn't have to like manage all these different tools and interfaces that, the same information is repeated, but out of date and, or edited by the wrong person who didn't have permission or something of that sort.
When you say AI in this context, what do you mean? Like, is it LLM type AI where you're like, I want to be able to, in my single pane of glass, be able to ask, like what would happen if I changed all the screws in this entire project from X to Y or something like that? Like, is it LLM AI? Is it, what is the AI?
Yeah.
Because there's also a version of what you're describing that's like enterprise software for sure, but doesn't necessarily, and like there's a big data component to it, but it's not inherently AI.
Yeah, no, it's like an exact use case, the one that you gave that, you would do. So we'll like record all our meetings. And that meeting you're having with a handful of different disciplines of engineers or people who understand the commercial of the agreement. And what that'll trigger through that recording is like a bunch of tasks for AIs to go do. And it's you just basically mentioned a trade there, right? It's like, what if we had, I don't know, one type of material over another type of material, one type of conveyance over another type of conveyance for this project or this material. Our AI will go explore that different design path. And that's a trade that you would give to an engineer. And you'd say, hey, go spend a week, like assess the trade-off between using, belt conveyance or pneumatic conveyance for some sort of material handling problem. And then tell me back, what do we feel like is the right kind of total cost of ownership trade? And it'll just explore that. And so that's an LLM who's doing a lot of that work. And importantly, you're not just kind of asking a ChatGPT or something of that sort to go explore that and produce something, which it'll do. And honestly, it'll do in a pretty impressive way. But it's the way that we've built it is that it's grounded both inside of the data for the project, because it has all that in one place, and then inside of the tools that we've fed it. So it knows how to use how to down select actual vendors, or how to read spec sheets that we've fed it, or how to use simulation software that we've fed it in order to derive these answers.
What you mentioned data centers, and I think you guys put that in as one of the categories you're most interested in your announcement when you guys unveiled. Is that because we're building a lot of data centers, or is that because there's like something specific to data centers, data center construction and engineering that makes it especially attractive here? Or is there something else that you would describe as like the perfect prototypical use case for this in the early days is X?
So these projects have a handful of different reasons of why you would apply this technology. In the data center use case specifically, speed is really an important lever for them. And so you can take, instead of the design portion taking, call it 6 to 9 months of your critical path, we can massively collapse that period of time. And that's really important for these data center projects to kind of accelerate how quickly we can actually build them. The same piece though with the fact that, if you right now budget 6 to 9 months for your design portion, almost none of that you're going to start to figure out, well, how do we optimize that design or do some sort of value engineering to save costs, or to design for long lead items, or to design for constructability. So really strong value prop in these data center projects. As we end up kind of increasing the capacity that we have on our team, though, it'll make sense to pick up basically many of these types of large industrial projects, of which we've already pushed the kind of technology to be able to demonstrate, and it'll end up being like really applicable across all types of construction.
So if you can deliver more certainty up front, then that presumably is the thing that unlocks a different kind of business model that hopefully solves the incentive problem. Is that just a fixed price contract with no change orders allowed, or what does that look like?
That's exactly it. We literally put like no change orders in our contracts.
So you wear
to
the
make it
risk.
explicit.
Like you wear all the
Yeah.
risk, basically. If there's a cost overrun, you're gonna go negative on the project. And the
Totally.
premise here is that because EPCs notoriously don't have huge margins, right? Construction firms are like high volume, low margin type businesses. And so I guess the thinking on your side has got to be, because we're reducing the cost of everything along the way, we naturally have higher margins, which would allow us a little bit of a buffer if things do become a little more expensive than we expected. At least we're not like in the red. Do I have that concept right?
Yeah, I mean, we definitely will have a different margin profile than the industry, but it's not that, because even when you think about it, the engineering margin, it's pretty small because the spend of the engineering is actually really small relative to the larger construction scope of the project. The important part of what allows us to absorb that risk without the kind of risk that we go into the red or at least in a risk adjusted way is because we've been able to do so much design up front. And we've been able to not only kind of like remove all of that extra risk by taking the definition instead of doing that at 30%, we can take that definition all the way through 100%. You just remove all this ambiguity of how much the thing should actually cost. So when again, traditionally, when someone gives a contract to go build a project, because they have such little core definition, they don't know all the vendors that they're going to buy from. They have, you even mentioned, I think, this example earlier of like, there's like a tariff risk. By the time that you fund the project and you commit to a cost, tariff can change in the 6 more months you need to finish the design in order to order the parts. That doesn't exist in our world because we've been able to just very, very quickly remove all this risk before we actually commit to a price. And that's very unique.
Wait, how does that work? So it's a good specific example. So I guess what you would do is issue the purchase order for all of the material before you commit to a price to the customer? Like, how do you avoid the tariff?
Yeah, exactly. It's timing it all out. So when just to compare this again to how it works today, is you'd only when you say, hey, we're the EPC, we're going to give you a performance guarantee or some sort of fixed firm price when you go to buy this or fund this project with like a notice to proceed or final investment decision. At that point, you literally don't even know all your bulks, like so all your commodity equipment, the steel that you need, the wire that you need, etc. We will know all of that at this point in time because we're not 30% definition, we're 100% engineering definition. And because we have this entire equipment list at this point in time, we know either how to say, hey, let's purchase everything at the same day that the project gets funded. Let's go either purchase everything or let's design hedges from a cost perspective so that we're not exposed to some sort of volatility or risk.
That's complex, right? I'm thinking of these big construction projects, right? And you're either on the day that you sign the contract, you're either buying all of the steel, just as a random specific example, or you're hedging steel prices at the project by project level to make sure that you don't overpay for steel. That's kind of what you need to do.
Yeah, that's what allows you to truly like have kind of a very different risk assessment for how these projects get built, and that what gives you a ability to do a fixed firm and actually mean it. Most of these fixed firms aren't really like industry themselves. I mean, we've seen time and time again where it's like a fixed firm doesn't really mean a fixed firm because there's inevitably some way that in the 1,000-page contract that you signed with your EPC, you went out of scope and invalidated that price, and hence the kind of change order trickery.
I guess the other thing that I wonder how you manage is subcontractors, right? Like it's another area where change orders come from not just the general contractor or the EPC having to make a change order, but also because some subcontractor made a change order. So do you have to flow this all? First of all, are you going to use subcontractors? You're just going to do everything in-house and have a ton of people on staff? And if you are going to use subcontractors, do you have to then flow this change in a structure down through all of them where they can't issue any change orders to you either?
Yeah, certainly long-term, we will do everything in-house. We will vertically integrate as much as possible because that's where you can fix the incentives all the way through. Yes, for these initial projects as we take, we are working friendly with like the local GC or even the trades, even the actual folks that we will subcontract a lot of this work out to. For that, it is making sure that we prior to entering into a contract, you have the kind of the same thing where often those contracts are not as the level of definition that you have when you're asking someone to actually give you a fixed price on what a scope of work is very hard. We don't have that same problem because we take things way deeper through definition, and we have a much better understanding of what should this actually cost to go build. So there's a handful of different ways that we kind of approach working with the actual subcontractors as we do this to hit our performance goals. But it is this kind of like a continuing loop of how do you remove more and more risk through design.
All right, so to wrap it up, you don't have to give me exact numbers, but like when should we expect to see the first COD? When should we expect to see the first project constructed by you guys?
I love it. We'll hopefully see next year. So hopefully by end of next year. Yeah.
Fast as the rule. Alex, thank you so much for the time. Really appreciate it.
I appreciate it. Thanks, Joe.
Alex Modon is the CEO and co-founder of Unlimited Industries. This show is a production of Latitude Media. You can head over to latitudemedia.com for links to today's topics. Latitude is supported by Prelude Ventures. This episode was produced by Daniel Waldorf. Mixing and theme song by Sean Marquand. Stephen Lacey is our executive editor. I'm Shail Khan, and this is Catalyst.